Okay, this is the Ogive question one for the Saturday workshop, May 7th that we're going to do. And let's just take a look at it. This comes from a national government exam. It's a little bit weird because they talk about this data, but they don't tell us anything about it. They don't tell us whether it's continuous or discrete data, and it could make a difference to the answer. So it's a bit of a funny question, but if say these are marks, well, maybe they're marks. Maybe this is, we're going to look at it, it would be discrete data. And that would mean you're just 0 to 29. So the marks, what I mean by discrete, it's either 1 or 2 or 3. It isn't a thing like weights here. So I guess it's marks in a question. So maybe it is there. You just have to do a bit of thinking. They give us a frequency here. From the people that got from 0 to 29, there's 2. 30 to 39 is 10 people. 40 to 49 is 43, and so on. In each interval, in each score, this is how many people got that particular mark. Now, a commutative frequency means you add it up as you go along. So it's 2 in the first thing. Then you take this 2 and this 10, you put it together, and it accumulates to 12. Then you go 12 plus 43 to get 55, and you keep adding to get the next accumulated score. There are 245 people, marks, tests that were done here, okay? So what you've got here is you're going to graph this thing. When you do an Ogive curve, what you take is this endpoint, 29, and you look at the commutative frequency. So 29 and 2, 39 or 40 and 12, 49 and 45. You actually go right to the endpoint there and the commutative frequency, those numbers. Now the first one is to say to draw an Ogive curve. Well, let's take a look. Here's the government version of it. Now it's interesting, they went right to 30 here, you know. In fact, you've got a graph here, it's got 30. And it's got 40, it's going right to there. It's not too clear on this thing here, but that 30 matches up right to there, and 40 goes right to that place, and so on. 100 goes right to that place. And all you do is you take those commutative frequencies, look what they've graphed. 30, each one of these is 10, 20, 30, 40, 50. So just go up a little bit to 30 and 2. And you should actually zero it here, right to 0. They didn't do that. That would be a good thing. And then 40 and a little bit more than 10 is 12. And then 50 and 55, right in between 50 and 60 there, 55. And then 60 and 127, almost to 130. And then 70 right where C is, all the way up straight to 180 right there. And they just graphed all these points here. There's 80 and 217. There's 200, 210, 217. And the last one, 90 and 240, a little bit above. And the last one, 100, is 245 right in the middle. And then you just kind of connect them in the best kind of curve you can. And there's your Ogive curve all done. You just have to make sure all those points are together and that you've sketched it. There, you've sketched your Ogive curve. Now the next question says, figure out the median and the lower and upper quartiles from the graph. Well, you know, they're only looking for estimates here, so you don't have to get too worried about it. What you do is you take 245, and you cut it in half. And 245 cut in half, let's see here, yeah, I'm going to read it off the graph here. 245 cut in half is pretty close to 126. So there's the middle. There's 100, there's 120, 126. If we go straight over and straight down, we get the median of 59%. So all you really have to do is take 245 and divide it by 2. Take 245 and divide it by 4, and you get pretty close to 50-something there. And if you run over and you run down, you get close to 51%. Now, you don't have to be exact here. So 245, I almost want to go get the calculator and divide it. Didn't do this thing here and now. But you just take it, divide it by 245 divided by 4. Go to that number here. Go over until you hit the Ogive curve and then run down. Then you go up here. 3/4 of 245 is pretty close to 180. You run over and you run down and you get a little bit more than 70. If you say 70% or 71 or 72, it's okay. So they get an upper quartile of 71%, a median of 59%, and a lower quartile of 51%. But you just have to be approximate. You don't have to be right on exact with that. Now this calculate the approximate mean from the data. This is the part that was a bit funny when I looked at it. They should have created this as discrete data, and they should have gone to 29 divided by 2 and got 14.5. 2 times 14.5. I think there's something a little funny here. But they pretended it was continuous data, that it was going all the way to 30, and they took half of it. And that's why they've got 15. There's 2 in the range of 15. And then there are 10 people in the range of 35, between 30 and 40. They just took the halfway point. But it's actually discrete data, so it really should be 34.5. But anyways, they went 10 times, they went to the middle. And then 43 people times the middle, 72 times the middle, 53 times the middle. Those are just the numbers. How many are in each 53, 37, 25, 3, all times the midpoint. And they took the midpoints as 80 to 90. They just did it like that. Then they added it all up. And they divided it by 245, how many people there were. And then they rounded it off and got 60.84%. You know, you could put this in your calculator, but in this question, it was quite a few years ago, they wanted you to show all the work of how it was working. And your calculator will do all this and give you that exact answer. Now, the last question was, can you look at these things, compare them, and talk about the distribution? Well, if you look at the mean and the median and the mode is the modal class here. We get it as 55%. Let's go back and take a look here. Do you see 72? So between 50 and 59, right in the middle, 55%. That's how they got the mode. They went to the middle of this class interval here. The modal class is actually 50 to 59. But that's where they got the 55% from. The median was 59, the mean 61. Hey, these are all very close. When the mean and the median and the mode are all pretty close to the same number, that means that the data is distributed symmetrically. It's not skewed data. So that's the story with question 2. Hey, that was quite a bit of work, but there you go.